Hello everyone. This is my third video on trigonometric equations. Unfortunately, the first time I was recording this video, I had problems with my headphones, and there is no audio recording, so I had to do it the second time. And I will try to add some of my talking, but it's going to be not really that easy. Alright, so this video is going to be about trigonometric equations. This is the part 3, and it's going to be the last one. I will solve here four equations from Polish exam called Matura. It is a Polish exam after the high school. We have two parts. The first is obligatory, and then there is the second part is expanded mathematics, and trigonometric equations, they are only on the second part. So it's like something extra in mathematics. Alright, so I will solve 4 equations in this video. Right? Okay, so let's start. I chose 4 a bit different equations so that you could see what kind of different methods and formulas we might need to use. Alright, example first. So there we have cosine x, then we have brackets, and we have sine x minus pi third plus sine x plus pi third. Let's close the brackets, equals to 1/2 sine x. Alright, so as you can see in the brackets we have a formula. As you remember in the first part, in the first video, I showed you quite a lot of formulas from trigonometry, and one of them is the formula for the sum of sinuses, right? So we have sine of one angle plus sine of second angle, and then we have a formula. So there you go. We are going to use this formula here, and as you can see, right, this is sine alpha plus sine of another angle beta, and we can use this formula here. And before I will use it in this particular equation, let's see the formula again. So it's 2 sine, then you have sum of two angles alpha plus beta by 2, and cosine alpha minus beta by 2. Alright, so we are going to use exactly this formula for this particular equation. So let's do it. Okay, and as you can see, pi third has reduced because we have minus pi third plus pi third. So let's just go. Let's just cross them out. In the second one, we have x's crossed out because we have x and minus x. And so you can see straight away that it's getting simpler, and the right side stays the same. Okay, and then what do we get here? So cosine x as it was, then 2 sine, and here we have x, because x plus x divided by 2 is x, then times cosine, you have negative pi third divided by 2, which gives us negative pi third. So we have cosine of negative pi third equals to 1/2 sine x. Okay, so it looks so much better than in the beginning. And of course, we have two sine x on the left and right side, which is really good for us, because if we take the right side to the left side, then we can take the sine x in front of the brackets. But before we do it, we still have to calculate cosine of negative pi third, which is pretty easy. The first thing to notice is that cosine as a function, it is an even function. So if you have cosine of negative angle, it's exactly the same as cosine of positive angle. So we can just get rid of the minus, and you have cosine pi third, right? And pi third is of course 60 degrees. So we need to calculate cosine of 60 degrees, and it's very easy because it's just 1/2. So we can put 1/2 as a cosine of negative pi third, and then you can cross out 1/2 with 2, right? We can just reduce them. Okay. Okay, there you go. 1/2. Let's put it there, right? And then we can just reduce 1/2 and 2. Okay, that's great. Okay, done. Okay, so now we're going to move to the second page and continue the equation. So what are we left with is cosine x times sine x and equals to 1/2 sine x. So now from the right side, let's go to the left side. This is very, let's maybe just write this down. So no division here. Just remember that it's always better not to divide. It doesn't mean that you can't, because you could divide, but if you want to divide the equation by sine x, you have to make the restriction that the sine x doesn't equal to 0. And by doing this, after that, you have to check what's happening if the sine x equals to 0, right? So you just make it a little bit more complicated. So you can divide it, of course, you can divide, but you have to follow the rules, and you have to be really careful because we cannot divide by 0. So you can do the division, but with certain rules. So I rather always encourage you not to divide, right? Just to try to do it different ways, and not doing all those, not do this restrictions. So what is better here to do is to take the 1/2 sine x and take it to the left side, and then we will take the sine x in front of the brackets, right? So let's see how it's going to work. So we're going to take 1/2 sine x to the left side. Yep, there you go. Okay, and now the last thing we have to do, take the sine x in front of the brackets. And that's it, basically. Yep, and now we have very good situation because we have multiplication which equals to 0, which is like the best thing ever when we talk about equations, any equations really. Is it polynomial, quadratic, or trigonometric? So if we have this kind of situation, we split the equation into two equations, which are very simple. We have sine x equals to 0 or cosine x equals to 1/2. And now it's just, we just need to take a look at the function, see where the sine x equals to 0. So let me draw very quickly the function. Okay, and here we have to look where sine x is 0. So as you can see, we have some points here, but remember that sine x and cosine x, these are periodic functions. So we have a period, it is 2 pi, so we only need to look at this particular period, right, between 0 and 2 pi, and then we add basically this period to our points. So we look at 0, 2 pi, we find 3 points, as you can see, 0, pi, and 2 pi, and then we need to add the period to each of the points, right? So we have 0 plus 2 pi, 2k pi, pi plus 2k pi, and 2 pi plus 2k pi. A lot of pi's here. And k is, of course, an integer, so just a simple integer number. Okay, and these are the solutions for the first equation, sine x equals to 0, and the second equation is cosine x equals to 1/2. So we need the second function, we need cosine x, right? So let's do it here, right? And the same situation, so we need only the part of the function between 0 and 2 pi, right? Because this is a periodic function, so we don't need the whole function. So between 0 and 2 pi, and now we have to look where we have angles which has this cosine 1/2. So let's take a look where is 1/2. And of course we start with pi third, so 60 degrees, because cosine of 60 degrees is 1/2. So we will start here. So this is pi third, and then we have to look, because we have another point over there, so beyond 3/2 of pi, and just remember to use the symmetry in this function, right? So the cosine and sine, they're quite symmetrical. So if we have pi third over here and you have the same amount like pi third and pi 6, then you can do it exactly at the end. So we can do it, we can calculate the point either by subtracting from 2 pi, subtracting pi third, or you can take 3/2 of pi and add pi sixths, right? So you can do it either way, right? So I'm going to subtract, so 2 pi minus pi thirds, and we get 5/3 pi. Okay, but as you can see, you can do it exactly the same with adding. So just to show you, you can do it various ways. You can do 3/2 pi plus pi over 6, and you will get exactly the same. So there you go. We have all the solutions. So we have 1, 2, 3, 4, 5 solutions between 0 and 2 pi, right? So between the period, and then we have to add this period. So we have to add 2 pi k, and we are going to write the answer just in a minute. Right, let me write just the answers for the second equation. So we have pi thirds plus 2k pi and 5/3 plus 2k pi, right? And at the end, when we are writing the answer, you can also just look at the answers and see if maybe some of the points could be written a bit simpler. And in this situation, we really can do it here, because if you look at the first equation, we have 0 pi and 2 pi plus 2k pi, where k is integer. So if you take a good look at these 3 points, you can see that we could just combine together all 3 options. So the first one and the third one gives you all even numbers of pi. So 2 pi, 4 pi's, negative 6 pi's, right? So all even quantities of pi's. And the middle one gives you an odd number, so 3, 1, -1, -3, -5, -7, right? So all together, if we just combine them together, so we can write all these 3 points as a 1 in the answer. So the only thing that we have to write here is going to be let me think, k pi, right? So if we take k, integer number, times pi, gives you all those 3 possibilities. All right, so let's write the answer. So we can write k times pi, where k is integer, and then we just have to add those 2 points from cosine x equals to 1/2. So we have 5/3 and 5 over 3 pi's, right? Okay, so let me write it. Okay. So of course we have an infinite number of answers here, because as we said before, the cosine and sine, they are infinite functions. They are periodic, but they are infinite. So there are just infinite number of answers here, but we have to write them somehow. So we have, there you go, 5/3 plus 2k pi and 5/3 pi plus 2k pi. All right, and this is the end of this equation. Right, great. Okay, there's a small like extra information here that you can look at cosine x not between 0 and 2 pi, but some people, they look at the function between negative pi and pi. So you could do that, of course. You just have to choose any part of cosine x in the period. So you can use negative pi and positive pi. Okay, right. So don't be surprised if sometimes you can see as the answer negative points. Okay, and the second equation here is cosine 2x equals to sine x plus 1. And here we have a much simpler situation, because we have restriction for x. It's x belongs to the interval between 0 and 2 pi. Okay, this is very simple kind of equations. During Matura exam, there were few very similar, and these are equations where basically you can use substitution and create a quadratic equation, and then solve it, right? So first of all, of course, we have formula for cosine of double angle, so that's what we're going to use it here. So we have cosine squared x minus sine x squared equals to sine x plus 1. And as you can see, we have two functions, and it will be so much better if we have just one function. So this is what we're going to do. So we are going to substitute cosine x by sine x because we have more sinuses, right? So let's do the substitution. How can we do it? Well, we need to use the most famous equation in trigonometry. So sine squared x plus cosine squared x equals to 1. And if we use this equation, which you can use always and everywhere in trigonometry, so it's a very, very important one, then we can substitute cosine as 1 minus sine x squared. Right, so let's put it there to the equation. Okay, so it's 1 minus sine x squared minus sine x squared minus sine x minus 1 equals to 0. So I took everything to the left side already, and now we can see that 1 goes that's gone, 1 and negative 1, and then we have minus 2 sine squared x minus sine x, and it looks so much better now. As I said, we could use a substitution here, because we could substitute something, but just take a good look at this equation, because it's even simpler that I thought, and we might really, well, we don't need the substitution. We could do it, right? So we could use the substitution, and if you had like another number here, so like 2 sine squared x plus sine x and like plus 2, then you would need to use the substitution to get quadratic equation. So you would use sine x as a t, and then t of course is between negative 1 and positive 1, and then you would get simple quadratic equation. And it's very good idea for this kind of equations, but this particular one is really simple, because as you can see, we can take sine x in front of the brackets, and we are left with 2 sine x plus 1, right? And yeah, multiplication equals to 0, so we split into 2 equations, which is so easy. So let's split into 2. So we have sine x equals to 0 and 2 sine x equals to 0, and we have 2 very simple trigonometric equations. Okay, so the sine x equals to 0, it's exactly the same as we had in the first example, so we can just use the answers from the previous example. So the answers will be 0, pi and 2 pi, right? And here, as you can see, we don't need to add the period, so we don't need to add 2k pi, because we have restriction for our x. The x must be from the period, from 0 to pi, so only these 3 points we can use here. And now let's take a look at negative 1/2. Which angles have negative sinuses and well, negative 1/2. So okay, let's see, 1/2. Right, so we know that sine equals to 1/2 for 30 degrees, so for pi over 6. So we know that here the point is 5/6. All right, but of course we want to have a negative half. So using the symmetry in the function, it's going to be these 2 points down here, and the only thing that we need to do here is calculate them. So here we have right, here is the same length, right? So we can draw like this, and we have pi over 6, those small bits. And what we have to do, we have to take pi plus pi over 6, right? So we have to add pi over 6, and on the right side we will have to take 2 pi's and subtract pi over 6, and it's going to be 12 minus pi 6 is 11 over 6 pi's, and there you go. And we have those 2 points between 0 and 2 pi. So overall we have 1, 2, 3, 4, 5 answers for this equation, for this very simple equation, right? Okay, so let's write the answer now. All right. Okay, so x belongs to, and we have 0. Right, let's write them in the increasing order. So 0, pi, 7/6, pi, 11/6, pi, and 2 pi. Right, lovely. There you go. Done. Second example, done. All right. So we can move to the third one. Okay. For the third and the fourth equation, I will not be recording the audio because as I said in the beginning, the first time I was recording the video, I didn't record my voice, so I have to do it the second time. And so I decided that I will do recording for the first two, and for the second two equations, I will leave you just with my writings, and hopefully you can just try maybe to do it yourself. First, right, try to solve the equation and then you can check the calculations. I will just say one thing to the third equation, because this equation is exactly the same as equation solved in the video number 2. Why I solved for the second time? Because this equation is a bit different and I decided to show you two versions how you could do it. Because you could use two formulas here. The one is exactly the same as in the video number 2, but there is also a bit different one. You could different approach, so you can just use different formulas. So it is a very good example, this equation, to see that usually, you know, when you see equations, you see the equation during the exam, it is constructed in the way that you should get to the simpler equations, right, at the end. So whenever you use whichever formula, usually you will get somewhere. So just be ready to try to experiment with the formulas and try to use them. So as you can see here, I'm just showing that you could see that there's like 7x, 2x, 9x. So we could easily notice that 9x is 7x plus 2x. So you have two options. You can use, so substitute 9x as a 7x plus 2x, and then use the formula for sine of the sum of two angles, which is going to be further in this video. Or you could see that we can get 7x and 2x by using different a bit numbers, so 9x and 5x, because if you use 5 and 9, and if you add them together, you will get 14 divided by 2, you get 7. If you divide them, so 9 subtract 5 is 4, divided by 2 is 2, right? So, okay, I'm just jumping here to the formulas to show you the formulas. Okay, so here we have some formulas that we can use. Okay, it was exactly the example from the second video. Okay, let me just wait a bit and I will just lead you a little bit here, guide you, because that's a lot. There's a lot happening here. So we have 4 formulas, and if we want to use the first one, right, so we cannot use 7 and 2 because that would just lead us nowhere. So we can use the first formula, but we have to use 9 and 5, right? And if you use 9 and 5, then you will get 7 and 2, okay? Right, let me see in a minute. I will write it here on the right side. Okay. Right, it would be very good for you just to discover it yourself and see, experiment which formula gives you this. So if we use 9x and 5x, right, and look, if we add and divide, it's 7. If we subtract and divide, we get 2. So we will get exactly what we want on the left side, which is really good, right? Because we're going to get there. And this is how we are going to do it in the first approach. So the first idea is to use this exactly. formula for 5x and 9x. Okay, so we have sine 9x plus sine 5x. Okay, I'm just writing here the formula itself. Okay, and then you can see that we can substitute, yeah, this 2 sine 7x times cosine 2x, and we can get here 2 times 2, so we get 2 times sine 9x plus sine 5x. And now it's going to be just very easy because you can easily notice that you have 2 sine of 9x on both sides, so they will just subtract themselves, and we will stay only with sine 5x, which is really good. Okay. Okay, and down here, I am showing you what kind of formula we could also use here to get the answer. So we would just substitute 9x as 7x plus 2x. And there's a different formula, which I'm writing here. See down here. And you could use this one, which I'm going to show you in the further in the video, and it would also lead you to the answer, but you have to be careful with these formulas. Okay, so please just pay attention to these writings, and I hope it will help you to understand what kind of formulas you can use in these different types of equations. So I'm going to just finish the first one, okay, and then I'll show you how you could do it with the second formula. Okay, so as you can see, we subtract 2 sine 9x and we get sine 5x equals to -1/2. Okay, and as I told you, I solved this equation in the video number 2, so just to see the answers, you can go there and check your answers. I only remind you here, which is very important, that we have argument here, which is not x, it's 5x. So anytime you have more than x, right, so you have some number with x, just be very careful, because then the interval that we have here will change. It's not going to be 0 pi. So the best way is to substitute 5x as a t, just a t, and then you have interval, which is bigger, because if you put x 0 pi, you will get 0.5 pi, the period, and then you have to look at the wider interval, so it's going to be 0.5 pi. And then of course you if you see video part 2, so just think about it, and then you can go there and check your answers. Okay, so just be very careful, because you will get more points that it might look like. So look for t and then calculate x from this simple equation. Okay, and I will quickly erase this just to show you how you could use the second formula down here. Okay, and we will get exactly to the same point, so we will get to sine 5x equals to negative 1/2, and then the end is exactly the same. So the most important thing is here to use the formula right. Okay, so this time let's leave the left side, right? As you can see, there's no change, but we're going to substitute 9x as a 7x plus 2x, right? And we are going to use the formula. So we have 2 sine 7x cosine 2x plus cosine 7x sine 2x negative 1. Okay, and then we can subtract and take to the left side. Okay, and we have 2 sine 7x cosine 2x, right, minus 2 cosine 7x times sine x, right, equals to negative 1. And now it's very important moment, because you have to notice that everything that we have on the left side is another formula. You just need to take 2 in front of the brackets, and then you will get sine 7x cosine 2x minus cosine 7x sine 2x. And if you check the formulas, you will discover that this is exactly sine 7x minus 2x. So what we're gonna get here is sine 5x. Right, and there you go. So it's another formula, but you will get to exactly the same equation at the end, right? So it's going to be sine, right, let me write here, 7x minus 2x, which gives us, of course, sine of 5x. And